Hello friends, we will continue our discussion on trigonometric functions. So we had proved till tan x minus y. We will continue with cot x plus y and cot x minus y. So we can write cot x plus y as cos x plus y divided by sin x plus y. So we can expand cos x plus y, which is cos x cos y minus sin x sin y. And sin x plus y is sin x cos y and plus cos x sin y. So we can divide numerator and denominator by sin x sin y. So we will get cos x by sin x, and the second term is cos y sin y minus sin x sin y divided by sin x sin y, it becomes 1. And the denominator, sin x is cancelled, so only cos y by sin y. Now sin y is cancelled here, so cos x divided by sin x. So we are dividing numerator and denominator by sin x sin y. So cos x divided by sin x is cot x, and cos y divided by sin y is cot y. Minus 1, and denominator is cot x plus cot y, or you can write cot y plus cot x. So this is the formula for cot x plus y. Now to find the cot x minus y, we simply need to replace y with minus y. So cot x minus y, this is equal to cot x cot minus y minus 1 divided by cot x plus cot minus y. So again cot minus x is cos minus x by sin minus x. So cos minus x will be cos x, sin minus x would be minus sin x. So the complete term will be minus cot x. So cot minus x is minus cot x. So this minus term I can keep outside. Minus cot x cot y minus 1 divided by cot x minus cot y. So we can divide numerator and denominator by minus 1 to get rid of these negative terms in the numerator. So we will get cot x cot y plus 1 and denominator the terms will change sign. So cot y will become positive. So I will write it first, then minus cot x. So this is our formula for cot x minus y. So here the condition is x, y and x plus y should not be multiples of pi, because if x plus y is multiple of pi, then this left hand side will not be defined, and if x and y are multiples of pi, then the right hand side terms will not be defined. Now we have cos 2x, sin 2x and tan 2x. So we can write cos 2x as cos x plus x, and then use the formula for cos x plus y, where both x and y are same. So cos x cos y, but here y same as x. So cos x times cos x, or we can write cos square x minus sin x sin y, but here x is equal to y. So directly we can write sin square x. So this is one formula. So here we have expressed in multiple forms. This is one formula. Cos 2x is equal to cos square x minus sin square x. Next is this 2 cos square x minus 1. So here in place of sin x we have put 1 minus sin square x, because we remember sin square x plus cos square x is 1, and then we have a third form 1 minus tan square x divided by 1 plus tan square x. So we will see all those forms. So cos square x minus, we can write sin square x as 1 minus cos square x. So this is our second formula for cos 2x. Now third formula was in terms of tan square x. So we can divide this term here by 1, and we have 1 as cos square x plus sin square x, which is equal to 1. So this is basically same as our the first equation, just we have divided by 1 in the denominator. Now we can divide both numerator and denominator by cos square x. So this cos square x will become 1, and then this will become sin square x divided by cos square x. And denominator again cos square x will get cancelled, and we will have sin square x divided by cos square x. So sin square x divided by cos square x, we can write this as sin x by cos x whole square, or tan square x. So numerator becomes 1 minus tan square x, and denominator is 1 plus tan square x. So this is our third formula for cos 2x. Next we have sin 2x. So again we can break it as sin x plus x, and it will be of the form x plus y, sin x plus y, which is sin x cos y plus cos x sin y, but here x and y both are x. So it will be sin x cos x plus cos x sin x. So we are using the formula for sin x plus y. So both terms are same, sin x cos x and again sin x cos x. So it will be 2 sin x cos x. So sin 2x is equal to 2 sin x cos x. So this is our one formula for sin 2x. So just like our earlier case, we can express sin 2x in the form of as a function of tan x. So here 2x we can either express break it into sin x cos x. So 2x we are breaking into x everywhere. So either we can break in terms of sin x cos x or we can break in terms of tan x. So we will just divide this term. This term we will divide by 1. So dividing a term by 1 does not change it. So 1 we will write it as sin square x plus cos square x. So dividing by sin square x plus cos square x we get 2 sin x cos x So we can divide by cos square x, then we will get tan in the numerator because this cos will get cancelled and we will have extra cos sin x divided by cos x, so we will get tan x. And denominator also sin square x by cos square x plus so one cos get cancelled with cos and one sin x divided by cos x remains. So we can write 2 tan x instead of 2 sin x by cos x. And denominator this is tan square x and this term is 1. So 1 plus tan square x. And this is our second formula. And as usual, since we have tan x here, it should not be odd multiples of pi by 2 because for odd multiples of pi by 2 tan x is not defined. And then we have tan 2x. So we can write tan 2x as sin 2x divided by cos 2x. And sin 2x we know is equal to 2 sin x cos x. Or we can directly use our formula for tan x plus y. That would be sort. We know that tan x plus y is tan x plus tan y divided by 1 minus tan x tan y. So we can write tan 2x as tan x plus x, and then write tan x plus tan x divided by 1 minus tan x tan x. So numerator becomes 2 tan x and denominator becomes 1 minus tan square x. So this is our formula for 2 tan x, tan 2x. So we have covered these three formula. Now we will see sin 3x, cos 3x and tan 3x. So 3x we can break as 2x plus x. So sin 2x we can write as 2 sin x cos x. This term, and then the remaining cos x. And cos 2x is 2 cos square x minus 1. First write it as cos square x minus sin square x. This term cos 2x. So the first term becomes 2 sine x and then cos square x. This cos square we can write as 1 minus sine square x. So that only sine terms are here in the second term. And this cos square also in terms of sine. One minus sine square x. So we have got rid of cos terms. And in the bracket 1 minus 2 sine square x. Now we can expand. So it becomes 2 sine x minus 2 sine cube x and the second term becomes sine x minus 2 sine cube x. So this 2 sine x and 1 sine x becomes 3 sine x. And this minus 2 sine x cube or sine cube x and this minus 2 sine cube x becomes minus 4 sine cube x. So this is our formula for sine 3x. Now next we have cos 3x. Again we will write it as 2x plus x. Cos x plus y is cos x cos y minus sin x sin y. So cos 2x cos x minus sin 2x sin x. Now in place of this cos 2x we can write 2 cos square x minus 1 and the remaining cos x here, and in place of sin 2x we can write 2 sin x cos x this term in place of this 2x sin 2x and the remaining sin x. So this sin x and this sin x becomes sin square x. So in place of sin square x I will write it as 1 minus cos square x because we want to get rid of sine terms. So expressed sine 3x in terms of just sine x, function of sine x, and in cos 3x we will write in terms of cos x. So this sine and this sine we wrote sine square x, and in place of sine square x we wrote 1 minus cos square x. So now we get 2 cos cube x minus cos x minus 2 cos x plus 2 cos x, 2 cos cube x. Now this 2 cos cube x and 2 cos cube x becomes 4 cos cube x. And 2 and 1 cos x becomes 3 cos x. So this is our formula for cos 3x. Next we have tan 3x. So we already know the formula of tan x plus y. We can break 3x as 2x plus x. So tan x plus y is tan x plus tan y divided by 1 minus tan x tan y. Tan 2x plus tan x divided by 1 minus tan 2x and tan x. And then we can expand this tan 2x term. So we had seen the formula for tan 2x, 2 tan x divided by 1 minus tan square x. So it becomes 2 tan x again we have tan 2x, so we will write 2 tan x divided by 1 minus tan square x. And then we have another tan x. So we can multiply everything by 1 minus tan square x, because this term is both in numerator and denominator. So we can get rid of these. So 1 here will be multiplied by this and tan x will be multiplied by this. So 2 tan x plus tan x multiplied by 1 minus tan square x divided by 1 minus tan square x minus tan x times tan x. This also becomes tan square x. So this tan x and minus tan square x becomes tan cube x. So this becomes 3 tan x minus tan cube x divided by 1 minus tan square x, 3 tan square x. So this is our formula for tan 3x. So we have seen 24, 25 and 26. Now cos x plus y we are writing as product of x plus y. X plus y y2 and x minus y y2. So so we have so sometimes like cases where we are asked to find suppose uh, we know x plus y, we know the value of cos x plus y by 2 and cos x minus y by 2, but individually we don't know what is cos x and cos y. For example, we may be knowing the value of cos 30 degree, cos 45 degree, cos 60 degree, but cos 15 degree we don't know. So we can always express 15 as difference of 45 and 60 or 45 and 30, like these terms. So sometimes these formula also come in handy. So we will see how to prove it. So we have to prove cos x plus cos y is equal to 2 times cos x plus y divided by 2 So this we can write as cos x by 2 plus cos y by 2, and this x by 2 minus y by 2. So we can start from right hand side. So we have 2, or we have another shortcut here, like if we add these angles, this is A and this is B. So if we add A plus B, we will get 2x and y will cancel out, 2x by 2, which will be x. So A plus B is equal to x, and A minus B if we do, we will get x plus y, this minus this x. So x will cancel out, this y will become in the numerator 2y and denominator 2. So A minus b is y. So we can use these two facts and we can get the result very quickly using this. So x we can write as a plus b, where a is x plus y by 2. So a is equal to x plus y by 2 and b is equal to x minus y by 2. So this we are assuming, let a is this, then we can write x is equal to a plus b, this thing, and y is equal to a minus b. So in place of x we will write a plus b, in place of y we will write a minus b. So cos, we have to find cos x plus cos y. So x is a plus b, then plus cos a minus b. So we will expand the terms. Cos a cos b minus sin a sin b. This is the expansion of first term, cos a plus b. Now we will expand cos a minus b, which is cos a cos b plus sin a sin b. This is the second term, cos a minus b. So here sin a sin b and sin a sin b minus sin a sin b gets cancelled, and we are left with cos a cos b plus cos a cos b. So 2 cos a cos b. And what is A? A is x plus y by 2 and B is x minus y by 2. So this is equal to 2 cos x plus y by 2 cos x minus y by 2. So our next expression is cos x minus cos y. So again here I will take the same values of a and b, so x and y would also be same. So this whole thing take at it, so we have to write again, but I will skip that part. So x we can write as a plus b, and y is a minus b. Now we will expand the terms cos a cos b minus sin a sin b. And now the second term cos a cos b plus sin a sin b. So this cos a cos b gets cancelled with minus cos a cos b, and we are left with minus 2 sin a sin b. Then in place of a we can put x plus y by 2 and b as x minus y by 2. So this would be same as cos x minus cos y. Then we will see sin x plus sin y. So again our a b would be same. So we will write a as this, b as this one, and x and y would be similarly a plus b and a minus b. So in place of x we will write a plus b, and in place of y we will write a minus b. Sin A plus B is sin A cos B plus cos A sin B. So this term and this term gets cancelled. We get 2 sin A cos B, and then in place of A and B we can write x plus y by 2 and x minus y by 2. Now I want to copy this entire thing. Paste it here for sin x minus y. Sin x minus sin y. So here again A is x uh, A is x plus y by 2 and B is x minus y by 2. So here it becomes minus instead of plus. So this term will remain same. It will become minus, and this will become plus. So sin A cos B will get cancelled, and we will have two cos A sin B. So in place of A, write x plus y by 2, and B is x minus y by 2. So this is equal to sin x minus sin y. So these four formula 27, 28, 29 and 30 are done. So we are left with these four similar looking expressions. So we can simply derive these from our previous four formula that we just saw. So here A plus B, so we can write cos A plus B. So here A plus B plus cos A minus B. So we can write it as this thing 2 cos So I will show it for one formula, and all three are exactly same as the other three. So this we are given, and we already know what is cos x plus cos y. Cos x plus cos y is 2 cos x plus y by 2 multiplied by cos x minus y by 2. So if we see this will be equal to this is x and this is y. Cos x plus y is 2 cos x plus y. So x plus y becomes a plus b plus a minus b x plus y divided by 2, and then cos x minus y divided by 2. So x is a plus b, y is a minus b. So it becomes minus a plus b divided by 2. So here b term is cancelled. So this becomes 2a divided by 2, which is a, and this becomes 2b divided by b, which is b. So we get 2 cos a cos b in place of this. So all other three are similar. So we can prove other three as similar cases to other three. So here we have cos a minus cos b in the second one. We already know what is cos x minus cos y. Then we have sin a plus sin v, sin x plus sin y, where x is a plus b, y is a minus b. We already know what is sin x plus sin y. Then we have sin x minus sin y. We already know the formula. So we can prove all of these. So using just this formula, we have proved the remaining. So the formula uh, that must be remembered are, I will highlight those. So clearly this we should know: cos minus x, sin minus x. So using this only we could find tan minus x, cot minus x, everything. So cos x plus y we must know. Then we should also remember cos x minus y. Then cos pi by 2 minus x, sin pi by 2 minus x. So the most important, I would say, is sin x plus y and cos x plus y. These two are most important. So these all are important. It will just automatically come to you when you practice more and more. You will just remember these on your tip of your tongues. So you would not need to think what is cos pi by 2 minus x. Or if you see sin x, you can immediately think how to break it So by writing it in terms of cos pi by 2x, this term will become simpler. So these things will come with experience. So from left hand side to right hand side, even if you remember, you should remember that where in place of sin x I can put this cos pi by 2 minus x to simplify my expression. So these things will only comes with experience, and if you solve more and more similar problems, then these things will automatically come to you. So although it is worth remembering, so these cos x plus y and sin x plus y, uh, these at least you should remember. Then tan x plus y, this also you should remember. And cot x plus y. So if you know plus y, you can simply change the sign of terms containing y. So that will do for x minus y. And then sine 2x and cos 2x, sine 3x, cos 3x. So is there some mistake here? What is tan 3x? Tan 3x we had written as 3 tan x minus 1 minus tan cube x divided by 1 minus 3 tan square x. So some formatting error is there. Oh, so basically one division sign is missing here. So this divided by this. So that's all for this lecture. We will see some more examples of trigonometric functions and trigonometric equations in our next lecture. Thanks for watching.